Hello everyone, and welcome to my presentation on HyLogger Mineralogy from CHIPS, a RoXplorer Pilot study. This pilot study provides the first insight into HyLogger results from the new MinEx CRC drill rig. Drilling is scheduled to commence in New South Wales from 2022 onwards, with the NDI areas South Cobar, North Cobar, Mundy, Forbes and Dubbo. Shown here on the right, you can see the RoXplorer drill rig set up on site. The drill rig uses a malleable steel coil, which has removed the need for the continual replacement of individual drill rods, and therefore makes it a much lower cost, faster and safer method when compared with conventional diamond and RC drilling. Additionally, the drilling fluids are recycled through the system, which provides major environmental benefits. Chip samples are produced from the RoXplorer, and a coarse fraction is separated for each 1 metre interval and collected in chip trays for logging and further analysis, including HyLogging. To date, 2 test holes have been drilled, including MSDP-15 from South Australia and Staveley 21 from Victoria. Here you can see the GS New South Wales HyLogger 3, a hyperspectral drill core line profiling instrument. Drill core or chip trays are loaded onto the XY table where the instrument uses infrared spectrometers to acquire spectra in the VNIR to SWIR and TAR wavelength regions. The SWIR region is best used for hydrosilicates such as micas, chlorites and clays, and is great for detecting mineralogical changes due to alteration. The TAR is best used for the anhydrosilicates such as quartz, feldspars and pyroxenes that are common rock-forming minerals. Additionally, spectra is co-registered with high-resolution imagery that is used for optimal interpretation. Data is typically collected on diamond drill core, however occasionally is collected on chips, pulps and hand samples. Spectral data is processed and interpreted in the Spectral Geologist software, where measured spectra is matched against a spectral reference library and information such as mineral chemistry can be measured using scalars. External data such as lithology and assays can also be imported into TSG to be compared against your interpreted results. For the pilot study, 4 trays from each of the RoXplorer holes were acquired for testing. On the right here, you can see the 2 holes, and circled in red is the tray selected. MSDP-15 trays were targeted from a range of different lithologies and from light to dark rock types to best test results. The project included 2 main aims. Firstly, to test the VNIR to SWIR and TAR spectral results for quality. Can we confidently identify mineralogy, mineral chemistry and lithological boundaries in the same way we do with diamond drill core? And secondly, was to develop a workable methodology for scanning chips. Here is an image of drill hole MSDP-15 with stratigraphic units labelled. The drill hole was drilled near Port Augusta and intersected through Adelaidean cover of the Gawler Craton and includes various shale units, carbonates and sandstones before it was terminated in the beta basalt. On the left is a close-up of some chip compartments where you can see the chip size vary between 1 to 5 millimeters. Shown here are the HyLogger results from MSDP-15. Unfortunately, most of the SWIR results were aspectral due to the dark colour of the shales which haven't reflected enough light for detection. Instead, we are only seeing the background noise. You can see that in the SWIR plot on the left with mostly grey coloured up. The small patch of yellow and blue is a lighter sandstone unit which shows up with white mica and carbonate. The thermal infrared is unaffected by colour and displays distinctive mineralogical changes downhole. The colours in the plot represent different mineral groups. We can see pink quartz, yellow-white mica, blue carbonate and brown plagioclase. On the right, I've plotted up thermal infrared mineralogy next to stratigraphy. We can see some clear changes with stratigraphic boundaries here. The top unit is mostly quartz, albite and white mica before a change to quartz, albite and carbonate in the Yarralina subgroup, and more carbonate, albite with lesser quartz in the Tapley Hill formation. Here is the TAR spectra stacked, where we can physically see those mineralogical changes in the spectra. I've labelled up the positions of some key features so you can easily visualise this. The 6500 nanometer carbonate feature is clearly absent in the top unit, while we can also see some clear changes with quartz, feldspar and white mica features at boundaries. Here I've joined the shortwave infrared with thermal infrared. Now we can physically see the low aspectral response from those darker shales, with no absorption features present. The spectra in the middle, with clear absorption features, is the lighter sandstone unit I mentioned earlier, and this can be accurately interpreted. Moving on into a look at HyLogger scanning test work. Test 1 looked at determining which colour chip tray is best to use out of clear, white or black. Recent work by GS New South Wales compared clear and black chip trays and found much better results from black trays due to the low reflectance of the colour. On the top right, we can see results from clear plastic chip trays with much more aspectral data that will require more masking. While on the bottom right is black plastic, where we have very little aspectral results and nice clean spectra. This pilot study further investigated chip trays by testing black plastic boxes that are twice the length of regular chip tray compartments. The aim was to provide a larger surface area to collect more spectra downhole and increase the surface area exposed to swirl lamps for improved reflectance. Here we can see the boxes with MSDP15 chips neatly laid out into a standard NQ core tray. The spectra shown on the left compares the clear plastic chip trays with the boxes, where we can see a large improvement in reflectance from the boxes. Here are 4 more examples from the lighter sandstone unit in MSDP15. We can see that in all cases the black boxes either showed an improvement in reflectance or were similar to the clear plastic trays. Test 2 looked at chip preparation for HyLogging. A closer inspection of Stavely 21 chips found abundant fine-grained material coating the surfaces of chips, and is likely a combination of fines mixed with drying drilling fluids. Clinging fines are well known to have detrimental effects to TAR spectra, which includes altering the shapes of features in quartz and carbonate. A subsample was extracted from 4 chip compartments and rinsed in a tea strainer under a running tap. On the right, you can see the before and after, which successfully removed nearly all of the fines. Here are the TAR results before and after rinsing. The stacked spectra on the right shows a clear increase in total reflectance of the spectra after rinsing, and the image on the left shows a comparison of single spectra before and after rinsing, where we can also see some volume scattering effects on the quartz before rinsing, with a degradation of the 8625 nanometer feature. For the shortwave infrared, rinsing chips made no major difference, with both reflectance and absorption features shown as largely the same here. Test 3 looked at determining the best HyLogger scanning mode by comparing regular 8mm line scanning and chip scanning mode. TAR results were relatively unaffected by scanning mode. However, SWIR results were much more sensitive. Where line scan collects and classifies much more mineralogy downhole, it also produces much more false positives, with minerals identified over plastic. For example, on the top right we can see epidote incorrectly identified in MSDP15 and is only occurring over the plastic section breaks. Here we are looking at individual spectra and comparing between line scan and chip scanning mode. Interestingly, line scan was found to consistently produce spectra with higher reflectance. This could be likely attributed to differences in lighting used between the scanning modes, with the orientations of lamps varying by 90 degrees between the 2 modes. For the thermal infrared, there was no discernible difference between the positions of absorption features or total reflectance between the 2 scanning modes, as shown here in the 4 examples. To wrap up, conclusions and recommendations included: HyLogger results were shown to identify mineralogy, mineral chemistry, and lithological boundaries on RoXplorer chip samples. Recommended use of black plastic chip trays with preference for 50 by 50mm 10 compartment chip trays. These can currently be purchased through commercial suppliers. Additional rinses of chips with inspections of chip surfaces for fines and contaminants before HyLogging. Preference for this would be at the drill site. Lastly, using regular line scan mode for HyLogging. Thank you for listening to my talk. Please feel free to contact me using the email address shown if you wish to discuss anything further.